In this video, we're going to try and work out this area here. So if you get a graph plotter and plot these parametric equations, it will trace out this path. So when time equals zero, put it into here, the x-coordinate will be 1. When time equals 0, put it into here, the y-coordinate will be 0. So this is your starting position when time equals 0. And then, if you get a graph plotter and plot it, it will trace out this path. So we are going to try and work out the whole area here. But rather than looking at the whole area, we will just concentrate on finding out this area. And then later on we can times it by 4. That will then give us the whole area. So in our Cartesian form, to work out this area here, in our Cartesian form, we would sum up all the strips we would need to sum up all the strips from 0 to 1. From 0 to 1. So we are moving, we are moving in the x direction. If you look at the thickness associated with this random strip here, the thickness is dx, is this dx. And each step of the way, we are moving in the x direction. Each step of the way, we're always going to need to find the height. And this is the height, the y is the height. So it's basically us summing up all the strips where we will need the height, and then we would need to times with the thickness. The thickness is dx. So this is in our so this here is the quarter of the area. So in our Cartesian realm, the area is given by this. But now we are in the parametric realm. So in the parametric realm, everything is driven by time. So everything's driven by time. So it will look like this. Everything is driven by time. So when time equals 0, the particle will be right here. So we are going to need to sum up all the strips from time 0 to the time it takes to get to here. Well, the time it takes to get to here is pi over 2. So let's say around here, let's say pi over 2. So when time equals 0, the particle will be right here. And then the time it takes to get to here is pi over 2. So we need to sum up all the strips. We need to sum up all the strips from from time 0. Remember, we are moving in terms of time because we're in the parametric realm. So we will need to sum up from 0 all the way. Well, the time it takes to get to here would be pi over 2. And then each step of the way, we're always going to need to know the height. Well, the height of this thing here, in the parametric realm, the height is always easy to obtain. It is this thing here. It is sine to the power 3 of t. Now, we need to know the thickness of this thing in terms of t. So hang on. We now need to know the thickness. Let me just zoom into let me just exaggerate the thickness of this strip. So the thickness here, this is the thickness here. We will need to know the thickness in terms of time. So hang on. So this is time here. When time equals 0, let's say at this particular point here, and let me just clear this up. So let's say at this particular point here, the time is let's just say it's here, and then a small change in time. So from here to here is your dt. So when it's here, it would be right here. Now a small change in time, that will then take you to here. So a small change in time, we need to find a way of obtaining from a small change in time, we would need to somehow obtain the small change in the x direction. So a small change in time, well, if you look at this here, if you find a differential here, so dx here, differentiate this would be 3 cos squared. 3 cos squared of t, and then times minus sine of t dt. Now a small change in time, when you combine it with this whole thing here, that will then give you the thickness associated with this strip. So because we're in our parametric realm, to find out, to sum up all the strips, we're always going to need the height. The height is easy to obtain. It is this thing here. To obtain the thickness, we would need to do this. Differentiate this. So it'd be 3 cos squared t times minus sine t dt. So a small change. Hang on. So a small change in time. So this is our dt. A small change in time. When you combine it with this, it represents the thickness of your strip. So to sum up everything in terms of time, so we are going to need to sum up all the strips. We are going to need to sum up all the strips from time 0 to time pi over 2. We're always going to need the height each step of the way. So the height is given by this. And then we will need to times it with the thickness associated with this strip. Well, the thickness is this thing here. The thickness is what we worked out earlier. So to find out the thickness, you would look at this bit here, and then differentiate it. So it would be this 3 cos squared t, and then you've got to times it with negative sine t, and then dt. So this here is your thickness. So this here is your thickness here. Okay, so now we are in our parametric realm. So in our parametric realm, we need to sum up. In our parametric realm, we need to sum up everything from time 0 to this point here, to time pi over 2. So we will need to sum up everything from time 0 to time pi over 2, and then we're moving in the time direction, if that makes sense. So the whole area is given by this thing here. I will continue in the next video. Okay.